Okay, this video tutorial looks at the mathematical strand of polynomials, and more specifically, we're going to focus our understanding on the remainder theorem. So, what is the remainder theorem? Well, basically, the remainder theorem is a quick way of determining if a remainder will be present when a polynomial is divided by a linear expression, all right, or another polynomial. And this sort of builds on our understanding of the factor theorem that we've looked at and uses a similar generic formula to determine the remainder. So again, we've got our factor, or our polynomial of p of x, and then we've got our divisor, or our linear expression of x, take k. In this particular case, if we substitute our k value into our polynomial, then our remainder will be our answer. So let's have a look at a couple of examples here. It says find the remainder when 2x cubed take x squared plus 15 is divided by x plus 3. So our x plus 3 is our x take k value. That means our k value is going to be minus 3, all right, which we can see here. We basically substitute that into our original polynomial and we end up with minus 48. So therefore our remainder is going to be minus 48. Another example, it says find a, given that we have a divider and it has a remainder of 12. So our k value here is going to equal 5 because of this expression. Our then polynomial is going to equal 12 if we replace x with 5. And you can see that in here. We collect all the like terms, and then once we get down to this stage, we simply solve the equation. Okay, so here are some practice questions I would like you to have a go at. Please feel free to pause the video. When you think you've got the correct answers, continue the video and we'll see how you went. Okay, so let's see how you went. The first question is asking us for our remainder. So remember that our remainder is equal to our p of k. All right, in this particular case, k is going to equal minus 4. So I'm going to substitute minus 4 into this polynomial. Oops. And I'm going to work out what my remainder would be. All right, now minus 4 all cubed is minus 64. Then I'm going to add 32. I'm then going to add 20, and I'm going to add 2. Now, if I do all that, I end up with minus 10 as my remainder. So my remainder is equal to minus 10. Second question says find a, given that this polynomial, when divided by x plus 4, has a remainder of 3. Therefore, my k value is again coincidental, minus 4. I'm then going to put minus 4 into this equation, or this polynomial I should say, and I'm going to make it all equal to 3. So therefore again I've got minus 64 plus 16a, take 12, take 1 is equal to 3. So minus 64, take 12 is minus 76, take 1 is minus 77. So minus 77 plus 16a is equal to 3. I then need to add 77 to both sides. That's going to get 16a equaling 80. So therefore a is 80 divided by 16, which is 5.